In order to understand astronomical concepts, you should have a fair understanding of motion, energy, and gravity. Now, see if you can notice that small red dot. I'm going to use it as a pointer. Well, let's start with the study of motion. Measuring motion. Now, when you want to study the motion of an object, it involves two fundamental quantities. What are they? A moving object changes its position. That's the first thing. There is a change in position. And this change in position occurs in a time interval. Now, the change in position of the moving object is called displacement. The moving object got displaced from one position to another. So the displacement is the final position minus the initial position. Now, the rate at which the position changes can be obtained by displacement, by dividing the displacement by the time interval. Now, the displacement is the final position minus the initial position. And if you divide that displacement by the time interval, then you get the rate of change of position. And the rate of change of position is called the average velocity of the object. Now, what is the difference between velocity and speed? Average velocity is the rate of change of position. Now remember, change of position always occurs from one position to another position. There is a direction associated with it. And therefore, average velocity or velocity of a moving object has a direction. Whereas speed does not specify any direction. If you divide distance covered by the time, you get the speed. Speed doesn't talk about any direction. All right. Now, let's consider the motion of a car. Now, we're going to use the x-axis for that. I'm going to draw the x-axis and the y-axis. We will see the motion of a car along the x-axis. Now, look at this. The car is at position x1 when we begin to observe it, when we start our clock. All right, and it moves to position x2 in a time interval delta t. Now you must read this as delta t. Delta stands for a small change. So whenever we want to represent a change in a quantity, we will use the letter delta. So delta t stands for a small change in the value of time. If I use delta x, that will stand for a small change in the value of x. Remember, this is not delta multiplied by t. Delta t is the notation we use to represent the change in time. So look at this. The position change from x1 to x2 in a time interval delta t. So the change in position is x2 minus x1. Final position minus the initial position. And therefore, what is the average velocity? Average velocity v equal to, now don't get upset with this notation here. V with a line on top simply means v bar. It means we are taking an average value of v. So v bar is displacement x2 minus x1 divided by the time interval delta t. Whereas average speed is distance divided by time. There is no mention of direction there. In the case of displacement, it's always the final position minus the initial position. You see, if you are here, and after some time you are here, your displacement is the final position minus the initial position. But the distance traveled, you may have taken a path something like this. So the distance is the length of the path, whereas displacement is simply final position minus the initial position. All right, so average speed is distance divided by time. You measure all this distance. That distance divided by time is the average speed, whereas displacement is the change in position divided by the time interval. Now, what is the unit for measuring velocity? Distance is measured in meter and the time is measured in second. Therefore, velocity is measured in meter per second. Now, what is the unit for measuring speed? The same thing, meter per second. All right. Now, if the velocity is uniform, what does that mean? Velocity is uniform. The rate at which the displacement changes does not alter. If the displacement, if an object changes its position by 2 meters every second, we say the displacement occurs at a uniform rate. So if v is the uniform velocity, then the relation between x, what does x stands for? X is the distance along the x-axis. You see, v stands for the change in x every second. Is that right? So we can write x equal to vt. V is the change that takes place every second. If you multiply that by t, you get the total change in x. So the distance along the x-axis is v times t. Now tell me, from your knowledge of elementary algebra, if you draw a graph of x on the y-axis, if you draw a graph of x on the y-axis and t on the x-axis, what kind of graph you will get? Now remember, in algebra you've seen the equation y equal to mx. Well, y equal to mx means y is directly proportional to x. X equal to vt means x is directly proportional to t. Now here, a graph of y versus x will be a straight line and its slope will be m. That's what it means. So in the case of x equal to vt, if you do a graph of x on the vertical axis and time t on the horizontal axis, its slope will be v, the uniform velocity. All right, so a graph of x versus v, t will be a straight line and its slope will be v. That's what I have depicted there. Now, how do you measure the slope? Slope is a change in the y value divided by a change in the x value. Now, I have denoted the change in the x value. This is our t2, this is our t1. So t2 minus t1, we will represent it as delta t. And the corresponding change in the y value is we call delta x. You see, change in the value of x. So slope is delta x divided by delta t, and that is equal to the uniform velocity. All right, let's now do a simple calculation based on this. A moving object changes its position from x equal to 3.5 meter to x equal to 6.7 meter in 2.5 seconds. What is the displacement and velocity of this moving object? Well, what is the displacement? Displacement is final position minus the initial position. So that will be x2 minus x1, 6.7 meter minus 3.5 meter is 3.2 meter. That is the displacement, change in the x value, delta x. And this displacement occurred in what time interval? It occurred in a time interval of 2.5 seconds. Therefore, velocity is change in the x value, change in displacement, change in position, divided by change in time. That is 3.2 meter divided by 2.5 second is 1.28 meter per second. All right. We will now look at the concept of acceleration. Now, when will a moving object be accelerating? Well, a moving object accelerates when the velocity changes. So when velocity changes with time, we say a moving object is accelerating. And how do you define acceleration? Acceleration is the rate of change of velocity. Now, you have actually seen this before, this kind of definition. What does that mean? Rate of change of velocity. It means a change in velocity divided by time. That's what the rate of change means. So, if the velocity changes from an initial value v1 to a final value v2, then the change in velocity is v2 minus v1 in meter per second. And that change occurred in a time interval t2 minus t1 in second. And the change in velocity we represent delta v. You know by now that notation. Delta v, the change in velocity, v2 minus v1. And the change in time is delta t. So acceleration is change in velocity divided by the change in time. Now, what is the unit for measuring acceleration? Look at the numerator here. The change in velocity is measured in meter per second, and the change in time is measured in second. What is meter per second divided by second? Now, look at this. Meter per second divided by second is actually meter per second times second in the denominator. It is meter per second squared. So the unit of acceleration is meter per second squared. Now, when acceleration A is uniform, a relation between v and t can be written as v equal to at. Now tell me, if I draw a graph of velocity on the y-axis and time on the x-axis, what kind of graph you will get? Well, it will be a straight line, and the slope of that graph will be a. There you go. Now, here again, I have shown how a time interval t2 minus t1 is taken on the graph, and a corresponding change in velocity v2 minus v1. Therefore, the slope is delta v divided by delta t, and that is a measure of the acceleration. All right, let's do a couple of problems. A car initially at rest attains the velocity of 25 meters per second in 5 seconds. What is its acceleration? Now, what is its initial velocity? Initially at rest. It means the initial velocity v1 equal to 0. And it changes its velocity to 25 meters per second. v2 is 25 meters per second. And this happened in a time interval 5 seconds. So, first we find delta v. Delta v is v2 minus v1. That is 25 meters per second minus 0 divided by delta t is 5 seconds. And so the acceleration is 5 meters per second squared. All right? These are very simple calculations. Another one. A car moving at 42 meters per second is brought to rest in 7 seconds. What is its acceleration? Well, The initial velocity is 42 meters per second. What is the final velocity? It is brought to rest. So the final velocity is 0. And this occurred in a time interval 7 seconds. So what is the acceleration? Acceleration is change in velocity, final velocity minus the initial velocity. Remember always that change is always the final minus the initial. The final is 0 and the initial is 42 meters per second. So it will be 0 minus 42 meters per second divided by the change in time is 7 seconds. And that is negative 42 meters per second divided by 7 seconds. That is negative 6 meters per second squared. Now what does the negative sign tell you about this motion? The negative sign tells you is that the acceleration is happening in the opposite direction as its velocity. In other words, as the car is moving that way, the velocity is directed that way, but the acceleration is directed in the opposite direction. That's what brings it to a rest. So the acceleration occurs opposite to the velocity. That's what the negative sign means. All right, let's now talk about the concept of momentum. We say every moving object has a momentum. And what does the momentum of an object look like? It is determined by mass of the object and its velocity. All right. Now, momentum of a moving object is represented by the letter P, the lowercase p, and it is measured as the product of mass and velocity. So can you write an equation for momentum? P equal to m times v. Momentum is the product of mass and velocity. There you go. Momentum is mass times velocity. What is the unit for measuring momentum? Mass is measured in kilogram. Velocity is measured in meter per second. Therefore, momentum is measured in kilogram times meter per second. So, momentum is measured in kilogram meter per second. How about a small calculation? Find the momentum of a 2000 kilogram car moving at 5 meters per second. We have the mass, we have the velocity, therefore we can find the momentum as P equal to mass times velocity. That will be 2000 kilogram times 5 meters per second, and that is 10,000 kilogram meter per second. All right, now an important concept, it's very important in astronomy, conservation of momentum. There are several physical quantities in the universe that are conserved. What does that mean? It means their total value does not change. Now, in a closed system, the total momentum of all objects will remain the same, although collision between objects can result in transfer of momentum from one object to another. Now, assume that you have a room full of moving basketballs. They're all moving. Now, while moving, they hit against each other, and some will slow down, some will speed up. Now, sometimes you go into the room and calculate the momentum of all the balls, mass times velocity for all the balls, add them together to get the total momentum. You go there after 2 days and calculate the momentum of each ball and add them together. The law says the total momentum you did on the first day should be equal to the total momentum you did the second day. That's what it means. In a closed system, that means there is no friction or anything from outside. The total momentum of all the objects will remain the same, although collisions between objects can result in transfer of momentum from one object to another. Okay, let's do another calculation on momentum. A car of mass 1000 kilogram changes its velocity from 10 meter per second to 20 meter per second in 5 seconds. What is the rate of change of momentum? Now, this is the third or fourth time we are seeing this notation, rate of change. What does the rate of change of momentum means? It means the change in momentum divided by time. That's what rate of change means. All right, let's calculate the initial momentum. The initial momentum of the car is its mass multiplied by its initial velocity. Initial velocity is 10 meters per second. And P sub I stands for initial momentum. Is mass times initial velocity, that is 10,000 kilogram meter per second. What is the final momentum? Is mass multiplied by final velocity, and that is 20,000 kilogram meter per second. What is the change in momentum? Delta P. See again that use of delta. Delta P stands for the change in momentum. Final momentum minus initial momentum, that is 10,000 kilogram meter per second. Now how do we find the rate of change of momentum? Divide this change in momentum by the time interval. So, rate of change of momentum is change in momentum divided by the time interval, delta P divided by delta T, and that gives you 2000 kilogram meter per second. Now, I want you to keep this in mind because I'm going to ask you in about 5 minutes this concept back, the rate of change of momentum. Look at the unit of the rate of change of momentum. The change in momentum is measured in kilogram meter per second. The time interval is measured in second. So the unit for the rate of change of momentum is kilogram meter per second divided by second is kilogram meter per second squared. We will come across this unit another place, and I'm going to ask you this. So, rate of change of momentum is measured in kilogram meter per second squared. All right, now we are talking about motion. So the question is, what causes motion? Well, Newton is the first who thought about it. He said all motion is caused by a force. So the behavior of all objects can be described by saying that objects tend to keep on doing what they're doing. What does that mean? It means if an object is at rest, it wants to keep on being at rest. If the object is in motion, it wants to keep on being in motion. If you are sleeping, you want to keep on being in sleep. Is that right? You hate getting up in the morning. Now, that is true about all objects. So if an object is at rest, they will continue in this state of rest. If an object is in motion, that object will continue to move continue to be in that state. Unless what happens? What can change this? The only thing that can change this is a force. So an object at rest will move only if there is a force acting on it. An object in motion can change that state only if there is a force acting on it. So Newton described this in a following statement. Now, what is the statement of Newton? He said an object at rest tends to stay at rest, and an object in motion tends to stay in motion with the same speed and in the same direction unless acted upon by an unbalanced force. What's an unbalanced force? Now try pushing the wall. Now, I'm actually pushing the wall now, but the wall is not moving. That means the wall is still standing there. The force I'm applying on the wall is balanced. It means the wall, when I push the wall to the right, the wall will push me to the left. There is no unbalanced force. An object will change its state of rest only if there is an unbalanced force acting on it. An object in motion will change its state of motion only if there is an unbalanced force acting on it. So this statement is called Newton's first law of motion. Now, you must be very familiar with that statement. An object at rest tends to stay at rest, and an object in motion tends to stay in motion with the same speed and in the same direction, unless acted upon by an unbalanced force. Now, if you look at this, how do you change the state of motion of an object? The state of motion can be changed by changing the speed or changing the direction. Is that right? Yes, or both. If an object is going this way, in order to make it go that way, you got to apply a force. That's what it means. To make it change the direction, you need a force. To make it change the speed, you need a force. Now, what's the concept of inertia? Inertia is the tendency of an object to keep on doing what it is doing. So the tendency of an object to keep on doing what it is doing is called inertia. Now look at this animation. Oh boy, why is he doing that? Well, he's in a state of motion, and the car was brought to rest and he's not wearing a seatbelt. He wants to keep on being in motion. That is inertia. All right, watch this animation. Watch this now. Whoa, boy. That's inertia. He's in motion and he wants to keep on being in motion. How about this? The ladder is in a state of motion and it wants to keep on being in motion. So all these illustrate the Newton's first law of motion. In the absence of an unbalanced force, an object in motion will maintain the state of motion. And this is very often called the law of inertia. Now, we've talked about Newton's first law. Let's now talk about Newton's second law. Newton's second law is describing the cause of acceleration. Now remember, acceleration means change of velocity, the change of motion. The only way acceleration can be produced or change of motion can be achieved is by using a force. So acceleration is caused by a force. And let's leave everything else and come back and concentrate on this. And Newton's second law gave us this relation. That is, force acting on an object causes an acceleration given by force equal to mass times acceleration. Now, I want you to make a small change in here. The force is not any force. It is an unbalanced force. Only an unbalanced force can produce acceleration. So in this case, I'm going to simply say F equal to ma, change it as F net equal to ma, F net, N-E-T. Net means unbalanced. So F net equal to ma means unbalanced force on an object equal to mass times its acceleration. All right. Now, what is the unit for measuring force? Well, tell me, what's the unit for measuring mass? Well, it is kilogram. What is the unit for measuring acceleration? You remember? You want to go back and take a look? It is meter per second squared. So, force is measured in the unit kilogram meter per second squared. Well, tell me, about 5 minutes ago, I told you to remember this. Kilogram meter per second squared. We found something else was measured in this unit. What was that something? It is the rate of change of momentum. Well, what it tells you is that rate of change of momentum of a moving object is a measure of the net force acting on it. You see, both these are the same thing. F net equal to ma, force equal to mass times acceleration. And force is a measure of the rate of change of momentum. All right, this unit, kilogram meter per second squared, is actually called a Newton. Remember, these are Newton's laws. So the unit of force has taken his name. The unit of force is called a Newton, and we represent it by uppercase N. And what is a Newton? A Newton is kilogram meter per second squared. All right, let's do a small calculation. What is the net force on a 1,000 kilogram car that accelerates at 5 meters per second squared? Well, net force is mass multiplied by acceleration. F net equal to ma. That will be 1,000 kilogram times 5 meters per second squared is 5,000 kilogram meter per second squared is Newton. All right, what I would like you to do now is complete this table. You can actually earn 2 extra credit points by doing this, and I will include this as an extra credit among the assignment. So submit this as an extra credit work and you can earn 2 points. All right, let's move on. What is Newton's third law? Well, the third law talks about 2 objects. It says when an object X exerts a force on object Y exerts an equal and opposite force back on X. Do you remember I told you I am pushing the wall? I am pushing the wall now, but the wall is not moving. Why? Because I'm exerting a force on the wall, and the wall is exerting an equal and opposite force on me, and that means the wall doesn't move. Well, sometimes this is a very commonly used statement. You say for every action there is an opposite and equal reaction. That is the common statement of third law. All right, let's move on. Let's now talk about motion along a circle. So far we were talking about motion along a straight line. How do you make an object move in a circle? Now remember, when an object is moving along a straight line, in order to change that state, you need a force. So if a force is applied at right angles to the motion, the object is going to go along a circle. So in order to make an object move along a circle, we need a force that is acting at right angles to the direction of motion. We will talk about that as we move on. Now, when an object moves along a circular path, the radius, look at that, this is the radius. The radius rotates through an angle theta. So in the case of linear motion, we talked about the change in position in terms of x. In the case of rotational motion, what is changing is the angle theta. So here, the radius of the circle changed its position from the initial position OA to the final position OB, and we have an angular displacement here. So angle theta is called the angular displacement of the object moving along the circle. If this angle theta is described in a time t, then we can calculate the rate at which the angle is being described. Is that right? The rate at which this angle is described is given by theta over t. See, theta is the angular displacement that happened in a time t. So the rate at which this displacement occurred is theta over t. And this rate is called angular velocity. Look at that, angular velocity. Earlier, the velocity we talked about is linear velocity. This is angular velocity, and we used the Greek letter omega to represent angular velocity. And angular velocity is what? How do you calculate that? It is the angle described divided by the time interval. So omega equal to theta over t. Theta is measured in a unit called radian, not degrees. It's measured in radian, and time is measured in second. So omega, the angular velocity, has the unit radian per second. Now, this radian multiplied by second to the power of -1 is the same as radian per second. It means radian belongs to the denominator. So that's the angular velocity, rate at which the angle is being described. So angular velocity is measured in radian per second. How about angular acceleration? Remember, we said acceleration is caused by force. And we just said an object cannot be made to move in a circle without a force. That means if an object is moving in a circle, we can be sure that there is a force acting on it. Now, what is the direction of the force? The direction of the force is always towards the center. It is at right angles to the direction of motion. So, an object that is moving along a circle is always accelerating. The moment it stops accelerating, the moment you stop that force, the object will go along the tangent to the circle. All right. So a change in angular velocity causes angular acceleration. And a change in angular velocity is actually caused by the change in direction. So angular acceleration is the rate of change of angular velocity. How do you write it? Angular acceleration, we represent that by the Greek letter alpha. You see, Greek letter alpha is the same as the alphabet A that we use. Alpha equal to change in angular velocity, omega f minus omega I, divided by the time interval. That is delta omega divided by delta t. Angular acceleration is caused by a force that pulls the object towards the center of the circle. I just showed you that without this force, the object cannot be made to move in a circle. The moment this force disappears, the object is going to go along the tangent of the circle. So angular acceleration is caused by a force that pulls the object towards the center of the circle. And this acceleration is called the centripetal force. This force is called the centripetal force. Now, you see, in astronomy, we will be talking about the moon going around the earth in a circular motion, the earth moving around the sun. All these happens because there is a centripetal force. There is a centripetal force acting on the moon. There is a centripetal force acting on the earth. And that's what caused the earth and the moon go round in a circle. In the absence of a centripetal force, the object will continue to move along a straight line. All right? I want you to understand these concepts well. Maybe listen to this a couple of times. Okay. Now, acceleration can be caused by changing the speed or changing direction. Now, both can cause acceleration. Now, what is happening in a circular motion is the direction is continuously changing, and that is what causes the acceleration here. Also, the speed along the circle can change. Both these can cause acceleration. So, motion of an object along a circle is an example of acceleration caused by changing the direction of motion. Now let's talk about angular momentum. We talked about linear momentum. What was the linear momentum we talked about? We said linear momentum P equal to mass times linear velocity. Now, an object moving along a circle has an angular momentum. And if you look at this, suppose you have a small object going in circle around a massive object, like the moon going around the sun. Now, then the small object has an angular momentum. Angular momentum is represented by the letter L. That stands for angular momentum. And the angular momentum is given by this, m times v times r. So angular momentum is mass times velocity times the radius of the circle along which the object is moving. All right? So objects moving in circles have angular momentum represented by uppercase L. Angular momentum of a planet of mass m orbiting the sun with a velocity v at a radial distance r is L equal to mvr. Now, all these concepts, when I make questions, remember all the questions for the test are made directly from here. So if you understand all these, your test will be very easy. We talked about conservation of momentum early, conservation of linear momentum. In the same way, momentum is conserved in the case of motion along a circle as well. So just like linear momentum is conserved, angular momentum of an object is also conserved. Now, can you look at the skater spinning? Now, you have seen these processes. When the skater has the arms outstretched and spins, and then gradually brings the arms closer to the body, she will go spinning faster. Why? Because the momentum has to be conserved. Means the total momentum L has to remain a constant. Now, when she brings the arms closer to the body, this R, the radius, will become less. And to compensate for that, V has to increase. She goes faster. So that MVR will remain the same. You see that? Now, you remember in the last lesson we talked about a planet orbiting the sun in an elliptical orbit, and the sun is right here. And we said as the planet comes closer to the sun, so somewhere here, its speed is greater than when it is here. Why? Because when it is there, that is the value of r. And when it is here, this is the value of r. R is much less. When r is small, to compensate for the decrease in the value of r, the value of v has to increase so that the angular momentum L remains a constant. That's what happens in this case, and that is what Kepler talked about in its law. We will look at this again in this lesson. All right. Now, we talked about conservation of linear momentum and conservation of angular momentum. There is also another quantity that is conserved, that is energy. Well, energy comes in three major categories. Kinetic energy, we represent it by K. Potential energy, we represent it by U. So kinetic energy, potential energy, then the radiative energy. Now, conservation of energy says that the total amount of energy in the universe will remain a constant. But energy can change from one form to another. But the total energy will always remain a constant. Now, energy is measured in a unit called joule. I know I'm introducing too many concepts and too many names, but make a note of these things. And when we use it next time, you should be familiar with it. What is the unit for measuring energy? Energy is measured in a unit called joule, and we represent it by the letter J. Now, 4,184 joules are in one food calorie. I'm sure you know that. When you eat food containing 1 calorie, that is 4,184 joules. Now, let's take a little a break from here and see. Let's figure out what is a joule of energy. Can you figure out an object that has a mass of 1 kilogram? Can you? Well, if you have an object of mass 1 kilogram, and if you lift it through 1 meter, you see that is lifted through 1 meter. Okay, 1 kilogram object is lifted through 1 meter. The energy that you spend in doing that is about 10 joules. All right, in order to lift 1 kilogram by 1 meter, the amount of energy you spend is about 10 joules. Look at that. 1 calorie of food contains 4,184 joules of energy. And a normal adult is supposed to have an intake of about 2,500 calories. How many joules of energy are these? That's 10 million joules. All right. If you have this much of energy, how many kilograms can you lift through 1 meter? That's a lot of energy. Let's leave that for the time being and talk about conservation of energy. What does that mean? You see, the energy you get from the food, you use it up. You use it to run upstairs, you use it for jogging, you use it for all kinds of things to do work and spend energy. Right? But the energy when you spend, it gets converted to other forms. For example, when you run, you rub against the ground and producing heat. So in this universe, energy is continuously being converted from one form to another. Now look at this. The energy from the sun reaches us and we use it to make our life comfortable. Plants use that energy to manufacture food. We eat that to get energy. When we die and the plants die, all this energy get back to the system. But if you calculate the total energy at any given time, that total energy will be a constant. That is the meaning of conservation of energy. All right, let's move on. So the physical quantities that do not change, we talked about, are said to be conserved. And what are the laws of conservation we talked about? We talked about the conservation of linear momentum. Linear momentum is mass times velocity. We represented it as P, is that right? We talked about conservation of angular momentum, L equal to mvr, and we talked about the conservation of energy. All these are actually very important in talking about the universe and astronomical concepts. All right, what are Kepler's laws of planetary motion? I'm not going to spend much time on it. The first law, he said, planets move in an elliptical orbit. Now, we now know that in order to move along an orbit like this, there must be a force always directed towards the center. In other words, that is the gravitational force. The Earth is being pulled towards the sun all the time. And it is that force that gives this centripetal force for the Earth to go like that. So that is the first law of... What's the second law? Second law says the planets describe equal areas in equal intervals of time. That means as the planet gets closer to the sun, it moves faster. And it goes far away, it goes slower. And what does the third law says? The third law says if the period t is the time taken for the planet to go around once and r is its average distance, then t squared equal to k r cube, where k is a constant. In the last lesson we said t squared divided by r cube equal to 1. Well, we said t squared divided by r cube is a constant, and that constant is 1 when t is measured in Earth years and r is measured in astronomical unit. Right? Okay, let's move on. Newton's law of gravitation. And now, all this motion is actually controlled by gravity. The Newton said every object attracts every other object with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. For example, if you have a mass m1 separated from a mass m2 by a distance r, the force between them is directly proportional to m1 times m2 and inversely proportional to the square of the distance between them. How do you write that? Well, we write it like this. F is directly proportional to m1 times m2. That's the numerator, direct proportion. And r squared is the denominator, is inverse proportion. What does that mean? It means when r increases, force will decrease. If you increase r, the force between them will decrease. Now, when you write this as an equation, it will look like this. Force of gravity between two objects is a constant. This is a constant. This is called the universal gravitational constant. So Fg, force of gravity, equal to m1 m2 divided by r squared, and g is called the universal gravitational constant. Well, and it has a value 6.67 times 10 to the negative 11 Newton meter squared per kilogram squared. You don't need to worry about these units now. All right? Let's do a small calculation. Determine the force of gravitational attraction between the Earth, this is the mass of the Earth, and a 70 kilogram student if the student is standing at sea level. That is, the distance between the boy and the center of the Earth is this, the radius of the Earth. Well, we know the mass of the Earth given to us, we know the mass of the boy, and we know the radius of the Earth where the boy is standing, and we know the value of g. I just gave it to you. So put all these, and that's all for the calculation. That will be 688 Newton. Now, what that means is this boy is being pulled by the Earth by this much of force. Now, this force with which the Earth pulls the boy is called the weight of the boy. The weight of the boy. Now, very often we confuse between mass and weight. Now remember, mass is not the same as weight. Now, weight is a force. All right, let's talk about that as we go on. So, weight of the student is W equal to mg. Now, if you use g, some time ago I gave you, what does g stands for? G stands for, if you drop an object here, it will fall all the way to the ground with an acceleration. That acceleration is what we call g, acceleration caused by gravity. If you go to the top of a building and jump down, you will be falling down with an acceleration g, acceleration due to gravity. And it has a value 9.8 meter per second squared. Now, if you want to find the weight of an object, what all you need to do is multiply mass by the acceleration. Remember we said F equal to ma, didn't we? Well, in the case of you jumping from the building, the force is the gravitational force, and that will produce an acceleration equal to g, so that gravitational force equal to mass times g, and that gravitational force is what we call the weight of the object. So weight of the object is the force due to the gravitational pull of the earth. Now, if you do that, you get 70 times 9.8, 686 Newton. Not exactly the same as 688. The difference came because the value of G 9.8 is an approximate value. All right. Now, if you look at this, I have represented different objects at different distances. When a mass m is separated by another mass m, by a distance d, the force between them is F. What happens when one of the masses is doubled, keeping the distance the same? The force also is doubled. That's the meaning of direct propulsion. If both masses are doubled, the force becomes 4F. On the other hand, come over here and you see if the distance is doubled, all right, tell me, if the distance is doubled, will the force increase or decrease? Well, the distance is on the denominator and it is squared. So if the distance is doubled, the force is going to become a quarter of the original force. You see that? Why? Because it is in the denominator and it is squared. So 2d squared will become 4d squared, and you get 1/4 of the original value. All right, look at this and try to understand it. Another problem. Suppose that two objects attract each other with a force of 16 units. If the distance between the two objects is doubled, what is the new force of attraction? If the distance is doubled, what will happen? The force will become a quarter of the original 16 units. So the new force will be a quarter of 16, which is 4 units. Another one. Suppose that two objects attract each other with a force of 16 units. If the mass of both objects were doubled, and if the distance between the objects remained the same, then what would be the new force? What do you think? The mass of each object is doubled. That means the total final force will be 4 times the original force, namely 64 units. Okay. We talked about mass and weight. And your mass is the same whether you are on Earth, on the moon, or during a spacewalk. Wherever you are, the mass cannot change. But your weight will change. Your weight is a force due to pull of gravity on the object, which means if you go to the moon will pull you with a lesser force, your weight will be less. While your mass will not change, your weight will change if you go to the moon. So weight W depends on mass and acceleration caused by the force of gravity. And so we write W equal to m times g. In order to find the weight, we multiply the mass with g. That's how you find the weight of an object. W equal to mg. Weight of an object on the moon will be less than its weight on the earth. Now, a freely falling object experiences weightlessness. Now, what does that mean? If an object is falling freely, remember, if you have a weighing machine, this weighing machine, and if you stand on it, all right, that's you standing there, what you're doing is you're pressing on the weighing machine. Why are you pressing? Because the earth is pulling you. If the earth is not pulling you, you won't be able to press on it. So what the machine reads is actually the force that you are pressing on it. Now, It is actually marked in kilograms. Suppose it reads 50 kilogram. It is not actually measuring the weight but the mass, we say. You see, this should be marked in Newton to measure the weight. Now, that means if you are falling freely and if there is a weighing scale attached to you, you won't be pressing onto it. That means if you're falling freely, you almost experience weightlessness. Now, if a 10 kilogram object is placed on a weighing scale, it must read 98 Newton. But it is actually marked in kilograms, so it will read 10 kilogram. But you must tell your friends that what the weighing machine is actually measuring is the force. That should be 98 Newton, right? All right, how about, have you ever experienced when you go on an elevator, when the elevator begins to accelerate upward, the elevator floor will push you harder. Whereas when the elevator is accelerating downward, you feel as though the floor is moving away from you. You see? So when you stand on a scale, you are exerting a force on the scale. And the scale is exerting a force on you. And this force is your weight. And it is this that the scale is going to read. Now, that means if the elevator is moving with a constant velocity, if the velocity is constant, it will read your weight. If it is moving upward, it should read more. You see, if your weight is 140, if the elevator begins to move up, it will be reading more than 140. Why? Because you will be pressing harder on the scale. Whereas if it is moving down with an acceleration, if it is accelerating downward, it will actually read less because you're not pressing as hard. And if the cable breaks and the elevator and you fall freely, the scale will not read anything because you're not really pressing on it. You are weightless. All right. These are concepts. I will be asking you questions on these. Now, I would like you to look at these three questions. Take some time and look at these questions and see whether you can find the answers. All right? And answer these questions on the discussion board so that all of you will be able to share your ideas. Okay,